All right, 2.4 day 3. Go ahead and start with the warm-up and pause the video, try it on your own. And then I'm going to actually tell you the answer right now, so in case you got it, you can fast forward into the actual notes. So it is, let me look at my key here, g of x equals, don't forget that, that's the most common point I have to take off on the test, the entire test, x to the fourth minus 5x cubed plus 25x squared minus 55x plus 34. If you got that, go ahead and fast forward through me doing it and move on to the new material. All right, so g of x equals, I have x minus 2 is a 0, x minus 1 is a 0, x minus 1 minus 4i is a factor. I kept saying 0 as a factor. And then I also have, don't forget, 1 plus 4i. So x minus 1 plus 4i. Okay, so I will multiply the first two out just so that it's a trinomial and kind of like, I guess, out of my way. X squared minus 3x plus 2. And then I will distribute the negative to these two. So x minus 1 plus 4i, x minus 1 minus 4i. And now I will multiply those two. So I'm going to just copy this down again here. All right, distributing my x. X times x is x squared. X times negative 1 is negative x. X times negative 4i is negative 4ix. Distribute your negative 1. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times negative 4 is positive 4i. Last, I'm going to distribute my 4i. 4i times x is 4ix. 4i times negative 1 is negative 4i. 4i times negative 4i is negative 16i squared. While I'm at that I squared, I'm going to say it's the same thing as negative 16 times negative 1, which is positive 16. Okay, now I'm going to cancel out what cancels out, which should be anything with an I in it now. Negative 4ix, positive 4ix, 4i, negative 4i. So now I have x squared minus 3x plus 2 times x squared, a negative x and a negative x, which is negative 2x, and a 1 and a 16, which is 17. All right, now I just have to multiply these two out. Notice your i's should be gone. You should never have anything that's quote-unquote ugly looking. Okay, x squared times x squared is x to the fourth. And then I have x squared times negative 2x, which is negative 2x cubed. X squared times 17 is 17x squared. 4, 3, 2 pattern. Okay, so I'm pretty confident I didn't make mistakes there. Distribute your negative 3x now. Negative 3x times x squared is negative 3x cubed. Negative 3x times negative 2x is positive 6x squared. Negative 3x times 17 is 30 plus 21 is 51. Minus 51x. Okay. All right, 3, 2, 1 are my exponents, so I'm feeling good about that also. And then finally distribute your 2. So I have plus 2x squared minus 4x. And then 2 plus times 17 is 34. All right, combine like terms. And also, oops, pattern, 2, 1, 0. Okay, I don't think I made a mistake anywhere. So this was g of x equals x to the fourth cubes, negative 2x cubed, negative 3x cubed, which is negative 5x cubed, squares 17, 6, and 2, so that's 25x squareds. X's, negative 51x and negative 4x is negative 55x, and then plus 34. And there's that final answer. Okay, so next what we're going to talk about, the last part of 2.4 is, it says if we're given one complex zero of a polynomial function, we obviously can use the fact to come up with another complex conjugate, the other complex zero. knowing that we have complex conjugate pairs, okay? So what we're going to do here is that we're going to use the fact that zeros come in complex conjugate pairs along with polynomial long division to find the remaining zero, okay? So in example 1, we're not going to do all of it. We're just going to talk about it. Actually, no, we do all of it. I'm going to do all of it in example 1. So let's just get started here. Okay. So it says, given negative 3i is a 0 of that polynomial, find the remaining zeros. So since one 0 is negative 3i, then we know another 0 has to be 3i. So there, we got 2 of our 0 so far. But if you look, I have 3 total, unless one repeats. But if you think about it, we already have 3i, negative 3i. The other one can't be imaginary because they come in pairs. So there has to be a third one that's a real one, okay? So what we're going to do is we can use the product of these factors. So the first factor is going to be x plus 3i from this 0 and x minus 3i from this 0 to get a real factor of the polynomial. So what we're going to do is we're going to take the product of this. We're going to multiply it out, okay? So if you need to multiply it out off to the side, you can. X times x is x squared. Outer is negative 3ix. Inner is positive 3ix. Those cancel. Last times last is negative 9i squared, which is the same thing as x squared plus 9. So now I know x squared plus 9 is a factor. If it's a factor, that means when I divide by that, I'll get the other factor, right? Because if it's a factor, then my remainder is 0. So since it's x squared plus 9, we cannot use synthetic division. We have to use polynomial long division. Okay, so let's actually do this problem. It says, given negative 3i is 0, find the other zeros. So off to the side right here, I'm going to put a little line. This is going to be my answer line. This is what I do so I don't forget answers. And I'm going to end up boxing it when I'm done. So gave me negative 3i is a 0. I already know positive 3i is a 0. Okay, so there's 1. I just need the next one. I'm not listing negative 3i as one of my answers because they gave it to me. All right, so now what I'm going to do is I'm going to use polynomial long division to divide my polynomial, x cubed minus 5x squared plus 9x minus 45. And I'm going to divide that by this real factor right here, x squared plus 9. If you look, you already used this 0 and then this 0 right here. So that's where that x squared plus 9 is coming from. Okay, polynomial long division. What do I multiply this by to get this? That's x. I'm going to put it up there. Distribute your x to these two terms. That's x cubed. And then 9 times x is 9x. Make sure you put that underneath the x. Subtract that. I don't like subtraction, so I'm going to change it to addition and distribute my negative. These cancel. This comes down here, so that's negative 5x squared. These cancel. I'm going to write plus 0x in case I need a placeholder for it. And then minus 45. All right, so now I'm going to start over. What do I multiply this by to get this? Negative 5. Distribute. That's negative 5x squared. Minus 45. Subtract. I don't like subtraction. I'm going to change it to addition and distribute my negative. These cancel. There's none of these. These cancel. 0. So now I know my other factor is x minus 5. This is my other factor. Other factor. So now remember what I'm finding, though. I'm finding all my zeros. So if x minus 5 is a factor, I know 5 is a 0. So there are my 2 zeros. So I got that once again by doing x minus 5 equals 0, x equals 5. Not too bad, right? And what's nice is that you know that you're always going to get 0 here because you're finding a factor. You're given a 0, you're finding a real factor, so you know that you're going to get a remainder of 0. Okay, next one. Given 2i is 0 of that polynomial, find the remaining zeros. Okay, so once again, answer line right here, which I'm going to end up boxing. If 2i is a 0, negative 2i is another 0. Most common mistake people make is that they list 2i as an answer, which was given to you. You don't list it as an answer. Or they forget negative 2i. So make sure you put that on your answer line right away. Okay, so now I want to find a real factor. So if x plus 2i is a 0, I know x minus 2i is a factor. If negative 2i is a 0, I know x plus 2i is a factor. So now I'm going to, these are two imaginary factors. I want a real factor. So I'm going to multiply it out because I know the i's will go away. I can change the I squared to something else. X squared. Outer inner cancel. Last is minus 4i squared. So this is x squared plus 4. All right, polynomial long division. I'm going to write down my x to the 4th plus 8x cubed plus 16x squared plus 32x plus 48 divided by x squared plus 4. Now, if you ever do your polynomial long division and you don't get a remainder of 0, you clearly made a mistake somewhere. Most likely, you made a mistake right here. You probably said that was negative 4 on accident. So always go back, like just be careful with that because I don't want you to do all this work to realize that you said that negative 4i squared is the same thing as negative 4, which it's not. Okay. What do I multiply this by to get this? It's x squared. I'm putting that above my 16x squared. Now I'm going to multiply it out. X squared times x squared is x to the 4th. X squared times 4 is 4x squared. Make sure you write that under the 16x squared because you can't subtract it from a cube. Distribute your negative. I don't like addition or subtraction, so I change it to addition. Gone. This I'm going to bring down. That's 8x cubed. That's plus 12x squared plus 32x plus 48. All right, so you're starting over. You're starting over. What do I multiply this by to get this? 8x. Distribute your 8x. That's 8x cubed plus 32x. Subtract. I don't like subtraction. I'm going to change it to addition and distribute my negative. These cancel. I'm going to bring this down. That's 12x squared. These cancel, so I can put plus 0x, or you can just put nothing there, plus 48. All right, starting over. X squared, what do I multiply it by to get 12x squared? That's plus 12. Distribute 12x squared plus 48. Notice everything's going to cancel out there. Boom, 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 0. Okay? All right, so remember, this is my other factor. This is my other factor. Now I want to find my other zeros. So I need to set that factor, x squared plus 8x plus 12, equal to 0 and solve. Okay, this is factorable. Two numbers that multiply to give me 12 and add to give me 8 are 6 and 2. Divide by your lead coefficient, and you get x plus 6 and x plus 2. And now I know my other two zeros are x equals negative 6 and x equals negative 2. So notice I have 4 zeros total. They gave me one. I had to find the other 3. Okay? Sometimes one of them is repeated, so you might get like negative 6 and negative 6. You would only write it once, but that doesn't happen a lot. All right. Let's try example 3 together, and then you can do example 4 on your own. I'll just tell you the answers for example 4. I'll show all the work in case you make a mistake, but at the beginning, in case you need to fast forward to the calculator problem with me. Okay. Given 3 plus I is a 0, find the remaining zeros. So once again, here's my answer line that I'm going to make into a box. X equals 3 minus I, oops, that doesn't look like a minus. 3 minus I is also a 0. I never made it into a box. Okay, there we go. All right, so now I need to find my real factor. So off to the side here, I'm going to say, okay, x minus this, so 3 plus I, and x minus the one I wrote on the answer line, 3 minus I, are imaginary factors. So now I'm going to find real factor. X minus 3 minus I, x minus 3 plus I. Multiply this out. X times x is x squared. X times negative 3 is negative 3x. X times I is plus ix. Distribute your negative 3. Negative 3x plus 9 minus 3i. Distribute your negative I, that's negative ix, plus 3i minus I squared. While I'm at my minus I squared, I'm going to say this is negative 1, so negative 1 is positive 1. And then I'll say 3i and negative 3i, negative ix, and positive ix. If you ever get that something's not canceling out, like you're like, oh, I have a 3i and a 3i, one of them's wrong. Okay, they have to cancel out. All right, so this becomes x squared minus 6x, and then 1 and 9 is 10. So there's my real factor. So now I'm going to use polynomial long division and divide by that. Okay, well, if you look here, 1, 2 zeros so far. It has 3 total at most. So I'm going to find one more 0, and it's going to be real. Okay, x cubed minus 4x squared minus 2x plus 20 divided by x squared minus 6x plus 10. All right, what do I multiply this by to get this? That's x. Distribute it. X cubed, excuse me, times, and then distribute negative 6x squared. Distribute plus 10x. Subtract. Distribute your negative. This is gone. This is 2x squared minus 12x plus 20. All right, start over. What do I multiply this by to get this? That's a plus 2. Distribute 2x squared minus 12x plus 20. So notice I got the exact same thing I had above. So when I subtract it, it's obviously all going to cancel out. All right, so this is my other factor. So I can find my other 0 by setting it equal to 0 and solve. And I get x equals negative 2. And there's my 2 zeros. Notice I did not write x equals 3 minus I, comma, negative 2, okay? When you're writing x equals, you cannot, when you're listing your zeros like that, x equals negative, or 3 minus I, x equals negative 2, you have to write x equals for each. Okay, go ahead and pause the video. Try this one on your own. When you unpause, I'm going to tell you answers first. All right, so the answers are x equals 2 plus 3i, x equals negative 2, and x equals 1/2. So if you got that, you can go ahead and fast forward to example 5, the calculator problem. If you didn't, or you got stuck somewhere, let's look. X equals 2 plus 3i is a 0. So now I'm going to say x minus 2 minus 3i, and then x minus 2 plus 3i are factors. Distribute the negative. X minus 2 plus 3i. X minus 2 minus 3i. Multiply that out. That's x squared minus 2x minus 3ix. Distribute your negative 2. Negative 2x plus 4 plus 6i. Distribute your 3i plus 3ix minus 6i minus 9i squared. Cross this off, change this to a positive 9. Okay, negative 6i and 6i, 3ix and negative 3ix. So this is x squared minus 4x plus 13. Okay, polynomial long division with that. X squared minus 4x plus 13. And then my polynomial I'm dividing is 2x to the 4th minus 5x cubed plus 12x squared plus 47x minus 26. All right. What do I multiply x squared by to get it to be a 2x to the 4th, which is 2x squared, so that goes up here. Distribute that. That's 2x to the 4th. 2x squared times negative 4 is negative 8x cubed. 2x squared times 13 is 26x squared. 3x cubed minus 14x squared plus 47x minus 26. Start over. 3x. That's 3x cubed. 3x times negative 4x is negative 12x squared. 3x times 13 is 39x. All right, that's negative 2x squared. That is positive 8x minus 26. All right, start over. That's negative 2. Negative 2x squared plus 8x minus 26. Good. All right, so this is my other factor. And I need to, so this is my other factor. So I need to find my other zeros. So I'm going to set that equal to 0 and solve. Now I'm hoping that it is factorable. If not, I would have to use the quadratic formula. Two numbers that multiply to give me negative 4, because 2 times negative 2, and add to give me 3. I can do that. So 4 and 1 of them has to be negative. That'll be that one. Divide by the lead coefficient of 2. This simplifies to 2 over 1. So this is x plus 2 times 2x minus 1. And I get x equals negative 2 and x equals 1/2. And there's my 3 additional zeros. Okay. So notice we pull everything from this chapter together to do this type of problem, right? Okay, and the last one, find the complex zeros of the function. Use a calculator, sketch a graph, right? All right, so we are going to go ahead and pull up our calculator here. So go ahead and get your calculator out. If you have to pause the video to go grab yours, do it. Okay. No, clear. There we go. You can see the whole thing now. Okay, so I'm going to graph this. Y equals x to the 4th, plus 3x cubed. No. Get out of there. There we go. Plus 3x cubed. Get out of the exponent. Minus 19x squared. Plus 27x minus 252. And I'm going to hit graph, hoping that, okay, my normal graph paper's there. Ooh, and I can see 1 0 so far. And I can see 2. So 2 zeros is always good, like when I have a 4th degree, because I know that I can like knock out the first one, knock out the second. Then I only have 2 left, which means there's a quadratic left, and I can solve any quadratic. Okay, so first off, it wants a sketch of the graph, and I know it doesn't look like 2 horizontal lines. So what I'm going to do is, let's think about this. 4th degree polynomial, so even, which is same direction. Positive lead coefficient, so it's going to be upward facing. So I know I'm missing the bottom of my graph because this is the 2 ends of my graph and it's upward facing. So if I want to see what the whole graph looks like, I need to get my y values. Once again, I need to make my y values bigger, or my negative y values. So I'm going to hit window, make my y min negative 20 and see if that helps. Hit graph. It's still not long enough there. So I'm going to go window negative 50. So it looked like I was still far from it. Graph. Nope. All right, window negative 100. I just want to see what the bottom of the graph looks like. Negative 100. And I'm going to change this back up to negative 10 because that's what it's supposed to be. Still nothing. All right, so I still have nothing. Now I have to think, okay? What's my y-intercept? Because I'm like, keep on changing it and changing it. It's not happening. My y-intercept, when I plug in 0, I get negative 252. So I'm going to say, okay, never mind. Let's go to my window and change that to negative 300. See how it's sometimes trial and error until you actually think. And it's Ooh, I almost got all of it there. So I'm going to do window negative 500. So I could have, looked at my notes and been like, oh yeah, I already did this last year. It fits at some point. But I want you to see that sometimes it's trial and error. Sometimes you have to, in order to see what your graph looks like, you have to mess with it. You're the window, that is. Try negative 600. Good enough, right? I can totally see what it looks like now. Okay, so I'm ready to sketch this. So here is my x-axis. Here is my y-axis. Ooh. And then my graph, I'll just do it in a different color. So, are you serious? Okay. So it hits here-ish, and then it hits here-ish. And if you look what those values are, that's x equals -7 and x equals 4. I can tell by looking at it because of the tick marks. And then it keeps going through that forever, and it keeps going through that forever. My hand keeps hitting it. And then it dips, comes in, hits at like -252. So it goes like this, and there. Beautiful, right? Okay, so clearly you can see there's two. I'm getting rid of this calculator because I can't even right now. Okay, so you can clearly see that there's two real zeros at x equals -7 and 4. But if you look, there's 4 total, and it's not bouncing there. So that means there's two imaginaries. So let's find the two imaginaries. So we're going to start by using synthetic division because we can, because these are zeros, right? If I knew I was dividing by x squared plus 10, then I couldn't. But this is x plus 7, and this is x minus 4 that are factors. All right, so synthetic division with a -7. 1, 3, -19, 27, and -252. And yes, you could have started with the 4. All right, drop that. That's 1. Multiply, that's -7. Add, that's -4. Multiply, that's 28. Add, that's 9. Multiply, that's -63. Add, that's negative, that's 3, 3, 6, 30, 36. You have a calculator too. And then multiply, it's 252. It is. Come on, it's going to cancel out there. It's a 0. All right, so now remember I have to continue. And 4 is also a 0 because I'm trying to break it down to a quadratic. Right now, I broke it down to a cubic function. Drop this, that's 1. That's 4. That's 0. That's 0. That's 9. That's 36. That's 0. So now I've broken this down to a quadratic. Because remember, this was a quartic. This was a cubic. This is a quadratic. So this is x squared plus 9. If I want to find the other zeros, I set it equal to 0 and solve. X squared equals -9. Square root to solve. And I get my other two zeros are positive and negative. I is going to be my answer, and the square root of 9 is 3, so 3i. So there's my 4 answers. Okay? Now, these directions, they find the zeros, but on your test, I could also ask you to factor it completely with real factors. If I did do that, it'd be x plus 7 times x minus 4 times, and then here's my other factor, x squared plus 9, which is not factorable. Just so we realize that. It didn't ask it, but it's nice to see it. Okay, that